Question 27, bundle 7, module 2. Y is equal to negative 2.x, y is equal to x square plus 8x plus k. In the given system of equations, k is a positive integer constant. Okay, noted. The system has no real solutions. Again noted. What is the least possible value of k? Whenever we have word problem, we mark the key points. So first key point is like k is a positive integer constant, so we will answer accordingly. We have to find the least possible value of k when the system has no real solution. Let's solve this question first and then we will understand why we are solving the question this way. So theoretically, when the system of equation has no real solutions, that means d is less than 0, right? Now, if I see these two equations, and because this is equal to y and this is also equal to y, so I can write this equation as, right, adding 2.5 on both sides. And in this particular equation, if I compare it with the standard form, ax square plus bx plus c is the constant. So in this equation, a is 1, this one, b is equal to 8, this one, and c is equal to k plus 2.5. Okay, now we have to apply d is smaller than 0. What is d? B square minus 4ac has to be less than 0. So b is 8, 8 squared minus 4 times a is 1 times c is k plus 2.5. It has to be less than 0. Now we have to solve the equation. So 8 squared is 64 minus 4 times 1 times k is 4k. Negative 4 times 2.5 is negative 10 is less than 0. So these are like terms. 54 minus 4k is less than 0. Okay, let's subtract 54 on both sides. Now, I cannot cancel negative sign here directly, right? Okay, multiply by negative on both sides and this will become this. No, that is wrong. In inequalities, whenever we multiply or divide by a negative sign, inequalities flip. So this one is greater than 0. Now it's correct. Note down this point because whenever we are in stress, we make this mistake. So dividing by k on both sides. So that is 54 by 4 and k is greater than 13.5. Now let's come back to the question. K is a positive integer. So what is the first or the least positive integer which is greater than 13.5? That is k, 14, right? The proper value of k was asked, not like what will be the values of k. It was not the question. Otherwise, this would have been the answer. We have to answer one positive integer constant, which is the least possible value of k, which is 14. Okay, we have solved our question. But now let's try to understand why we did that. What we do, that whenever d is less than 0, then there is no real solution, right? And when d is equal to 0, then both the solutions are same, right? Both roots same. And if d is greater than 0, it will have real roots but unequal, right? It will have again real roots and both equal. It will be real but unequal. Now the question is, what is the concept behind it? So if we use the quadratic formula, the two values of x are negative b plus minus square root of d by 2a. That is the quadratic formula, right? And d in turn is b squared minus 4ac. Now all depends upon this d, right? If this d is less than 0, as in this case, then this number will be an imaginary number. If d is less than 0, this number will be an imaginary number, because whenever the numbers are like this, these numbers are not real numbers. So this is depending upon this, right? Now if this d is equal to 0, then both roots will be minus b by 2a, because adding or subtracting 0, is remains the same. And when d is greater than 0, that means it is a positive number. And when it is a positive number, the roots will be, one will be of positive sign and another will be of negative sign, but both will be real. So that is the reason behind that we calculate d whenever we have to find the roots are real or the roots are not real, right?